Hi Doctor, we are from BFC 44903 Structural Steel Design Section 3 Group 1 student, and the title we design is Steel Truss Design of a Stadium, and group members are contained Kumun Kit, Lau Jianping, Ling Yan, Ng Kai Chi, and Nor Zuhaira Atika. My name is Ng Kai Chi, and now I'm going to present about the project overview. The stadium truss is designed by steel structure, which is the purpose for badminton court for competition, and it is designed as an indoor stadium with the steel framework, and the type of truss design is Warren truss. Design concept and erection methodology is Warren truss contain a series of isosceles triangle or equilateral triangles, and every diagonal component is the same length within the Warren truss, and less complex planning for building structure, interior space use, and future expenditure of professional and trained workers. From the diagram is showing the cross section of truss section, and the advantage of Warren truss is ability to distribute loading properly and uniform across the truss members. The second is do not require a large amount of material to be built or construct, and the third is make use of rich triangle, which make them extremely strong. Next is showing the structural design of stadium that we selected. And this is the stadium's truss geometry. Next is showing the cross-sectional front view of our stadium. And this is showing the cross-sectional side view of our stadium. This is the plan view of building design that we draw from the AutoCAD.
Hi Doctor, my name is Kumun Kit, and now I will present the project specification. First of all, the type of truss we use is Warren truss, and the type of beam we use in this design is universal beam and universal column. The connection type for the stadium is bolt type, and the steel grade we use is S275. The spacing of truss is 6.2 meter and spacing of purlin is 3 meter. Then I will present the load composition on the truss. First of all, the cell width of the truss is 0.55 kN per meter square, and the weight of roof sheet, insulation, and purlins is 0.39 kN per meter square. The variable load is 0.75 kN per meter square, which is found on referred to the Euro code. Then the load act on the truss is 1.35 GK plus 1.5 QK. So the total load act on the truss is 2.394 kN per meter square, and the point load act on the truss is 44.52 kN. After all the load combination is known, we proceed to the purlin design. The WP in the purlin design is 21.2 kN. Then we use the Z equal to WPL over 1008, and the value calculated is 73.02 centimeter cube. Then the D equal to L over 45. We use 6,200 divided by 45, and we get 137.77 millimeter. Furthermore, the B equal to L over 60 is equal to 6,200 divided by 60, and the value we get is 103.33 millimeter. After all this value is calculated, we propose the steel structure for the purlin is equal L section, which dimension is 150 times 150 times 15.
And now it's my turn to continue again the part for the calculation of internal force of Warren truss. At first, we calculate for the determinacy of structure, and based on the calculation, we know that the support RB was removed and the real force will be determined as the next page. And the next we can get for the real force by using the joint method, and the virtual force by using the joint method also. And then we can calculate for the actual internal force based on the calculation of real force and virtual force. And this is showing the reaction force through the stat pro. this is showing the internal force of truss in step pro. And we can get that the internal force of manual calculation and the internal force in the step pro by comparison, then we can get that the calculation and the result that we get is almost the same.
Assalamualaikum. My name is Zahira Atika binti Sahrudin. I want to present calculation of compression and tension of Warren truss. Okay, next I want to present compression in truss. Okay, first kita akan design of bottom chord. Bottom chord ni kita akan kira compression member. Okay, yang ada lukisan tu kita dapat daripada internal force daripada stem pro. Okay, kita akan cari maximum design force iaitu NED 103.40 kN compression. Okay, so kita akan cari cross section. Untuk kita cari cross section, kita akan tengok dekat kita punya yang belakang tu lah, buku. Lepas tu section property, section classification, akan ada nominal thickness. Okay, akan ada, kita akan cari the overall section is not class 4. Okay, so kita akan cari compression capacity of section. Okay, next kita akan present compression capacity of section. Okay, kita akan design pressure resistant NCRD. Okay, so kita akan dapat 1182.5 kN. So kita akan cari untuk nilai NED per dengan NCRD dapat 0.09 kurang daripada 1.0. So nilai kita akan jadi okay. Okay, next kita akan facial buckling resistant. Okay, so kat situ kita akan dapat appreciation factor iaitu 0.34 and then kita akan dapat 1.88. Okay, next kita akan present radiation factor. Okay, C kita akan dapat 0.33 kurang daripada 1.0 iaitu adalah okay. And then kita akan buat the design buckling resistant. Design buckling resistant kita akan dapat NBRD. And then NBRD kita dapat 390.23 kN. And then kita cari ND per ABRD. So nilai kita adalah kurang daripada 1 iaitu 0.26. So nilai kita okay. Okay, next kita akan cari tension in truss. Okay, first ni second kita akan design of top chord pula, tension member. Okay, ni nilai daripada internal force 10 pro. Kita dapat NED kita 170.94 tension. Okay, and then kita cross section kita, size kita 150 darab 150 darab dengan 15L. Itu kita dapat daripada buku Eurocode kat belakang. And then kita cari section property, section qualification. Okay, so section qualification kita the overall section is not class 4. Okay, next kita cari tension capacity of section. Okay, kita design plastic resistant. Okay, NPLRD kita adalah 1182.5 kN. The design ultimate resistance kita dapat 1229.1 kN. Nnet kita adalah nilai A tolak dengan nilai Nnet. Nnet sama dengan A tolak dengan A whole, dapat nilai adalah 3970 mm. So nilai kita MPLD kita dapat 1182.5 kN. So nilai dia kurang daripada 1.0. So jadinya 0.14. So nilai dia okay.
Good morning or good afternoon, doctor. My name is Lau Jinping, and I will going to summarize the purpose sizing for compression member and tension member. Our group has choose the 5 most critical compression member and tension member. We have do the preliminary design, and for the more detail, doctor can see our calculation part in the report. So the minimum requirement area is 3,416 millimeters square. So each of the proposed steel area is different depending on the size of the steel. For the 5 most critical tension member, we have proposed 4 same size of the steel, which is 610 multiplied by 178 multiplied by 100, and only one is 203 multiplied by 123 multiplied by 25.
Hi doctor, I'm Linian with metric number F200174. I'm going to talk about the connection part. So for the steel structure, connection is used to connect two different steel parts together by using bolt or weld. For this project, the connection that we use is M20 grade 4.6 bolt. First, we will calculate the shear resistance. We know that the shear resistance per bolt is 47.04 kN. Then we proceed to the bearing resistance. After calculate the bearing resistance, we can know that the bearing resistance for in bolt is 273.486 kilonewton per bolt, and for the inner bolt is 353.584 kilonewton per bolt. By comparing the shear resistance and bearing resistance, we can conclude that the shear resistance is much more critical, thus the joint is controlled by the strength in shear. The overall shear resistance is 188.16 kilonewton for 4 bolts.
Okay, lastly, kita akan bincang pasal conclusion. Okay, first, the project involves analyze and design the steel truss stadium using both hand calculation and the STEM Pro program. Second, the stadium had dimension 36 meter, width and length 55.8 meter, and a truss height of 9 meter. The use of computer software program like the STEM Pro save time and ensure the soundness of the design. Next, the type of connection used in the structure were identified and justified for load transmission. Next, kita akan adalah the project provide practical experience in real engineering situation and the application of Eurocode design. Okay, next, specific steel member and design and size we selection for various element of the structure such as purlin and cord. Okay, last step Pro software was used for load analysis while AutoCAD was used for detailing. Okay, thank you.